Hello, my friends. Welcome to my talk about model-driven mixed reality apps for the Global XR Bootcamp 2020. I'll be talking to you from my study. The study in which I've been working and living for about half a year now, like everybody else, I guess. I'm sorry, this isn't a really good recording studio. I just have an old headset and an old camera and a lot of mess in the background. I don't have a green screen. I hope the talk will be interesting enough by itself to distract you from all the mess in the background. First of all, of course, I need to say something about myself because that's kind of mandatory, I think. I'm Joost van Schaik. I'm a senior mixed reality software architect. Uh, I call myself a developer plus plus. I work at Velikis. That's a startup in health, safety, and first aid training using mixed reality in Amsterdam, the Netherlands. We are still looking for talented developers wanting to join us. So please contact me if you may be interested. After this plug, I'm going to tell you I'm a Microsoft MVP, a Windows Dev and Insider, Windows Dev since about 2011. I have some nicknames. I am kind infamous as a blogger and not as a speaker. I don't do this very often. I hope it doesn't show too much. I am very noisy on LinkedIn. I'm extremely noisy on Twitter, as people who follow me know, especially during Microsoft events. I've been developing for 35 years. Yes, I'm that old. Thank you. For 28 years, people actually pay me for that, so that's nice. I come from the GIS, Geographical Information Systems. You can still see that because my three apps in the HoloLens store of the Microsoft store, my HoloLens apps that support both HoloLens 1, 2, and Windows Mixed Reality headsets, immersive headsets, all do something with maps or spatial data. As we say in Dutch, het bloed kruipt niet waar het gaan kan, or well, the blood goes where it can go. Let's see. What you can expect today is why should we use model-driven mixed reality apps? How can we do that? I'm going to show you a not so very spectacular demo and a lot of code. People who have seen my earlier talks or basically read my blogs know how I convey information. A little story, a lot of code, a little story, more code, and a demo. And so that's how we go. We end with a little bit of unit testing because that's a bit, I'll explain why, but mostly the hoops that Unity makes you jump through because unit testing itself is not so very hard or different, but making it work in Unity is. And so I will say something at the end that will make me sound like a wise man descending from the mountain. I hope you will agree. What you cannot expect is something like this, flashy demos. I don't even have a user HoloLens. It's laying in the back there. Yes, it's there on purpose. I don't show any visual effects because this is basically an architecture talk. So if you find that boring, please skip to the next talk. So the why. This is what a average Unity app looks. It's like a giant mess of behaviors, calling events, calling behaviors, calling methods on other behaviors all over the scene. And debugging is not very fun. Trying to find out how it works is not very fun. It works fine for demos and shortcut, but it's only if you try to find how it actually works or trying to write something bigger, you will probably end up here, and we don't want it. So, like I said, I was an MVP since about 2011. The clever calculating people will now have found out that I cannot have been a mixed reality MVP or an MVP working with mixed reality since then because HoloLens doesn't exist that long. And that's correct. I started out as a Windows Phone MVP. Uh, and once upon a time, these were things. I will wait a few seconds for you to finish laughing or end your cries of dismay. Good. Once these were a thing, and they came with XAML. XAML still exists, but in another way. XAML sports and supported and still supports data binding. It has behaviors. It has something like I notify property change. If you change a property from a class, you will get a notification and you can act on that on code. It came with observable collections that basically react to events like an object is added or deleted from a list, an observable collection. And this made for automatic populations or changes of list views. And there was something like MVVMLight, one of the very much frameworks or libraries for actually building model view model object applications. This supported all this, and it also supported messenger and dependency injection, which make it a rather awesome piece of equipment to make model-driven apps. The point of this all was that we had a clear separation between UI and business logic, the business logic on the left, and that allowed you to test the business logic by writing unit tests without having to fiddle with the UI too much. So you can at least make sure that the base working of your app work. So how do we get back to this lost land? Well, there is something like as UniRX. I found that with the help of my friends. Reactive extensions for Unity. They have a reactive property that gives a signal if something changes. You can subscribe to it. Sounds familiar. There is a reactive collection that gives um, events of when something is added, deleted, or removed or changed. Sounds familiar. There is a message broker. There is a scheduler. There is much more. And the global way how I use it is like this. We have a UI part. We have some other UI part. There is a state service. I use the Mixed Reality Toolkit services to put this in the air. I will explain later how this works. And this has one or two model objects. The UI part asks from the state service, give me a reference to the model. And then sends something to the model to ask, it changes something, well, change this property, and some other UI part can subscribe to the property and react to that. What we don't have is this. There is no communication between totally disparate UI parts, and that's the problem we always had in Unity, that things actually communicated over the UI or all through the scene. This is not what we want. I'm going to show you the first demo actually implementing this. It's very not spectacular. We have two toggles. Only when both toggles are set, the square on the top shows green, otherwise it's red. And I can also reset the UI. We have interaction between UI and model, but not between UI and UI. And I hope we can show that. Right, let's go to the first demo. Already started Unity, or else it will take forever. Here we have the first demo. And you can see here we have the two toggles. I press the first toggle, it still is red. I press the second toggle, it's green. I press the toggle, it's red. I will await your applause. I also written something to, like I said, it works with a model. I created something that you can actually show what's happening inside the model. So if I click this, you see with a property change, properties changed. This was something I created for MRTK 2.4. Then it broke down because Microsoft removed all the state inspectors that were inside the Mixed Reality Toolkit. So I kind of recreated it on top of something else. This is outside the scope of how this works is outside the scope of this talk, but I will talk about this later. So I will first explain in code how this works, and if you can't read code and don't understand it, there will be a little schematic afterwards. So, like I said, we have a service, the state service, and that's in here. It's simply it's the profile. The state service simply is a headstand for the two models that are part of this demo. What you can see here, we have here the two button model. This is the one we just used. If I press F12, this is actually the model. This is a reactive property. I can get and set it, and there is another reactive property. Important to see is that I always use interfaces, so because in a state service, I will show that in Unity, you can in Mixed Reality Toolkit, you can define an extension service. This is where it gets called, but it also implements an interface, and I retrieve it by interface. So by using this system, we can use dependency injection. One thing achieved. The two button model itself we have had. Then I go to the simple UI that actually drives this model. We have the two button controller, or toggle button controller. This simply gets, this is a shorthand, I will show where it comes from. To get to the button model, select one value to the current state of the toggle, of the actual UI toggle. The other side is exactly the other way around. Subscribe to the model and set the value of the interactable actually to this. So if the model changes, it shows it's changed the UI. If the UI changes, it shows it changed the model. And because this event is only fired when something changes, this won't go round and round. Notice this one, the R to this. Such a subscription is of course simply an event handler, and this would get stuck or take care of memory. If you add to this, it actually this automatically disposes when the controller, this is a behavior, is deleted. Well, the base controller is pretty simple. It actually gets the state by its interface. This is a bit of a dirty trick. It waits for about 1 second in a tight loop before the Mixed Reality toolkit is initialized and actually has loaded all the services. Now the reset button controller is even simpler. It simply sets all the properties to 0, to false. Oh, the toggle two button controller is basically identical because only it happens another property. There is obviously some room for improvement here. And then of course the selection state controller that simply listens to both properties. This is a nice one of RX. This combines the value of this property and this property, makes the lambda of it, and only if they're both and gives the value, it propagates the value if they're both true or false, both true, I mean. And if we subscribe to that, the value we get for it is like is in R. If R is true, it is green. Actually, then P and Q, ergo both properties are true. Or otherwise it's red, and also add to this to make sure this subscription is deleted properly when this scene is deleted or this behavior is deleted. So with combined latest, you can list a lot of properties, and this part will fire when either one of the properties change, if you just saw. Like I said, if this was a little bit too complex in code, I also made a little diagram. It works like this. We have a toggle service that has a model with a select 1 and a select 2 properties. This toggle already has an event, already has gotten the model from the state service. So it actually changes select 1, and if select 1 changes, it reads back. The same is for toggle 2, only another property, and the reset quad only listens to both properties. All the takeaways, I hope, we have a single sort of truth in the MRTK service, like the MVVM main view model that I usually made. We also can, that's even not in the slide. You can also use a simple form of dependency injection by making test models. I've showed you how to use the UniRX reactive properties, how you can subscribe to it. and our event registers, notice that the initial value is always propagated. So when you create a reactive property, everything that is subscribed to it will get the initial value. But every subscription will get the initial value or the current value. I'll do this for automatic cleanup and combine latest to combine two AMBU properties. Well, I would love to have questions now, but that's not possible. So we move on to the second demo. This is a bit more complex. How about the list display? Clicking a button adds a model to a list. A game object is then automatically created, and touching an object triggers an event that deletes. And I only do that by manipulating the model. Now there should be sound in this demo, but it doesn't always work. So I first open this thing again so we can see the list model. And if I started the right scene, it actually might show the right thing. Here we go again, open the states and the list model. So if I add, things will appear. I have to click this. You will see there is a model with a view. Of a view with a model. You can see this as a view. And if I touch one, the sound doesn't. And if I clear, it also disappears. What also is important to see, that if I select one in it, here is also the model in it. Okay, how this works, explaining how this works is a bit more complex. I will do my best. I hope you will can follow my path. First, I'm going to show you is this menu. I can stop it right now. This is the object menu. This has a list menu controller in it, and on every button there's simply a call to where is it, where is it, where is it. I always keep searching for it. There it is, the add method, and you have to believe this does the reset method. So the list menu controller simply is this. We add a new model, a simple demo model with a random value of for the location, and clear simply clears it. This is really all the UI can do. And the rest all goes by model manipulation. The object list model is the base of all of this. It simply is, it listens to delete messages, because I will get to that later. The heart of this is a reactive collection of a simple demo model. This is the simple demo, the model that's actually in here, that's created by the list controller. See, it makes a simple list model. And that's basically all it does, and you can subscribe to records. And it also processes the delete message, because an object can ask to be deleted, but it has no ID into which list it belongs. Well, the simple demo model is very simple. Like I said, it accepts an initial position, and that's a reactive property. And that's about all it does. If something says you must be deleted, it sends a delete message, an object delete message with itself as a payload, and something should then delete me, because I can delete myself because I have no ID to what I belong. That's the idea of being independent. Well, the object delete message is really nothing more than a typed payload handler. This is as far as the simple models go. It's really simple, and this lives in the state service. Now, the object controller is a little bit more complex. This is you might have seen it here. In the prefab, there is a simple object controller. That's the the child class of it. So that's the implementation. An object controller is simply something that accepts a model and does a process model upgrade. And when it gets a model, you should act on it. This is what you should override, and this is what you should implement. This gets into the reactive property then, but unfortunately you can't really show that because you can't really serialize it properly. You can not in the you can show that in the model. So I add a serialized field like a copy that will show. This is only for display purposes. So that's what makes it show up when you do this. Come on. This is what it makes it show up here. There's that field for. Right. That's the object controller. So then we go to the simple object controller, which is the implementation for this. Because if you do a model update, what must actually happen? Well, if we do a model update, we of course call the base, but this specific model supports a location. So we want to have this or models supports a location. The object controller itself is just type agnostic. So we need to do something with that property. We subscribe to the initial position, and we make sure that the position of this object equals that of the model. Delete just passes it on to the model, and on touch start should actually launch a delete. So if I start it, if something touches me, I want to be deleted. And this is only the result of this object, of this implementation of this interface. Oh, so that was the simple object controller. Now the demo list object controller is the actually implementation of a thing that actually creates and manages the list of game objects. And that's a pretty simple class, deceptively simple. The only thing it does is, okay, I start, we wait till the Mixed Reality Toolkit is available, and then we set the collection to manage to the shapes that are in the list model. Yeah, can we still follow that? It looks simple, like I said. It is less simple because this is the actual object model. Important to see is it supports a parent object in which the objects are created. This is a prefab that it should support. This prefab is this one, the sphere view. The sphere view simply has a lot of things that has, well, associated with the sphere plus the simple object controller. This dictionary is keeps track of all the models and the game objects that are created for. And when we, this is also where we start. Now this is the comment explains it. Now set collection is actually the place where it all happens. We clear existing subscriptions. We destroy all existing views. We make a composite disposable. This is this is not a model. This is not a behavior. So now we have to. I'm sorry. This is a behavior, but because the thing we are subscribing to can change, we need to manually track our subscriptions. So we use a composite disposable, and that will show how that works. And we add not to this, but to the proposable. When something is added to the collection we just got, use add, call this method. When something is removed, call this method. When the collection is cleared, call this method. And of course, if there are already objects in the collection, we need to create them. Process add is pretty simple. Okay, so we have a new model. We create a new view object for that in the parent. We find the model holder, which is an object controller. This is basically a behavior that's, well, I showed it, that encapsulates a model for the specific object. We set the model to the object holder, and we add it to the model list, the list of model and views. So now we know which model belongs to which view. If we remove the model from the list, if the list says, hey, there is a model removed, we find the accompanying view, destroy it, and remove the model from our list. Well, process reset destroys all view. That's not very complex. We just destroy all view, and of course we clear the views. And clear subscriptions disposes all subscriptions. If this code was a bit too complex, I can imagine that. I will have a little schema that will show what it actually did. So, the add flow. This is the add button. If I click add, I create a demo model and add it to the shapes. The shapes then send out an event, the model add, saying, oh, we have a new model. And the list controller is subscribed to that model, to that event, or to the observe add. And it says, oh, there is a new demo object model. I better create a 3D object for it. Spawn an object like it. I put the demo model on it, and I will register it in my list of views. That's what happened. Now, if you want to delete something, in this case a button, in that case a touch, calls the delete of the object model. Well, actually it calls the delete of the object controller, but let's not make some things more complex. So the object model throws out an object, I want to be deleted. And that ends up to anyone who listens to it, which happens to be the list model, who deletes it from the shape, who deletes it from the shapes. The shapes list then automatically sends out a message of an event. I have a deleted model, so whoever is interested, please delete whatever happens. The list controller gets this event, gets the accompanying 3D view, a 3D object, and deletes it from the view. This is what happens underwater. So, takeaways. We have a reactive collection. We have observe add, observe remove, and observe reset, and we can act on that. It's not very hard to do once you know what you do. We have saw the message broker to communicate between different parts of the application. Also not very complicated. The scheduler, that was a bit. I'll think I'll step it on a little bit more. That was in the where is it? Not publish. No. Here it is, scheduler. The idea is I'll wait for 2 milliseconds for actually to play the sound, because as soon as the object is deleted, the sound is gone, rather cut off. But for some reason, it doesn't work for the very first time. For the purposes of this demo, I thought like, well, it's good. The scheduler has a lot of more functions. Please have a look at it. It's very interesting. Now, and I also showed you the composite disposable. You can use that if you, for some reason, need to manage subscription manually. This happens, for instance, if, well, like I said, if the subscription or desubscription is not explicitly tied to the creation or the deletion of your behavior, or when it's not a behavior at all. I mean, in the application we're now making, we also have subscriptions on the in models on other part of the model. So those things are deleted. So you have to dispose them manually. So, and the point was we could test. So how can we test? Well, it turns out we can. In Unity, it's not that hard to do. You just open the window, test runner, and Then there's a test runner, and I will show you in Unity. So we do a window, general, it's no test runner. It's always, I always have to look for this. And then I have 3 tests and I can run them. Like this was the shortest demo I ever gave. It took a 0.5 less than 1/10 of a second. Wow. Now I wonder, while I was looking through the all services, if somebody noticed something funny about my solution. Too bad you can't tell me that, but I will tell it anyway. First of all, unit tests are in a separate project because they're here. And the second, my project is not called Assembly C#, which it usually is. I need to explain this, how to set up Unity tests, because it's actually more complex than running unit test itself. And I will do so by doing slides, or else it will take forever. So, like I said, this test runner, right? Setting up Unity tests. Allow me for some yak shaving. So, if you start up unit test for the very first time, it says create edit mode test assembly files. For now, I will not go into play mode editors testing. If you do so, great. It creates a folder. You can name that folder, and you have a folder. Then you wait a little, you wait a little more, and then finally you can actually create a test script. You open that test script in Visual Studio, you call your object model, and it says, I cannot find reactive native demo. Oh, well, it turns out you need to do some things to actually get this done. And I hope there are some Doctor Who fans in here. So I don't have a sonic screwdriver with me, but I'll try to explain the process as necessary to set it up. Here we go. So there is something you can do to actually use assembly deference. For God's sake, never click this button, or else you will go down the rabbit hole. The test assembly only has these references. So with this button, you can actually add references. Great. And then you will find there is no assembly C#. So how am I ever going to make a reference? Turns out you have to define your stuff to be an assembly itself. That's what I mean with yak shaving. So we say do in the root of our project, we do of our assets folder, we do assembly definition file, and we're done. Yeah, right. Your main project is now called Reactive Native Demo, just like mine, and you will get a gazillion compiler errors. Mostly for Microsoft package. It took me quite some time to find out what was happening, but apparently in Assembly C#, all the package reference are done automatically. Unfortunately, to other assemblies, they are not. So you have all the to add them assemblies manually, all of them. And that wouldn't be a problem if it were not the Mixed Reality Toolkit is actually divided into a lot of assemblies. Yeah, a lot of assemblies. So you have to add them manually one by one, and you have to know which one they are. And you don't have to forget some. Maybe you need some other things that are from Unity. This can be a lot of work. This anyway. You can use the lazy dev approach. I have simply found out all mixed reality there are, and probably can be used by your test project. The idea of dividing up your project up into test projects is in little assemblies is it makes compiling makes more efficient. Because if you change something in an assembly, it will only compile that assembly. So if I was building the Mixed Reality Toolkit and I was only changing something in async, the compiling of the whole toolkit was a lot simpler. But now it works against us. I have found out which projects there are, and you can also just edit this in text in my textpad. Notepad. Ooh, I'm old. It's showing my age. Notepad++, and add them to this file manually. I will, of course, show a link in the end with which file with this project, and you can actually just download it and copy it into your file and save a lot of trouble. Anyway, once you've done that, you come from your test object. You can see the add a reference to your project plus every other type of project. Often, if you use classes that are only in Mixed Reality Toolkit, then we have a problem. Sorry, that was a notification. I thought I'd turn them all off. I didn't. You can now finally select the React Native demo, and now you can actually do the unit tests. Oh, that's okay. So that was setting up the unit tests, and you can actually run them like I showed you at the beginning. It was a little bit. So wrapping it up, okay. We have a single source of truth in the Mixed Reality Toolkit service. Like MVVM, we have a main view model and we have a single source of truth, and we can actually use dependency injection. UniRx reactive property. I showed you how to use UniRx reactive properties, reactive collection, Nexus broker, scheduler, and lots more. You can subscribe to register an event. You can use combine latest to add multiple events. You can add to this for automatic cleanup. I also showed you how to set up and run unit tests, mostly set up and run. And I have showed you more things like the subscription tracking. And I also want to show you tell you there's really lots more to see in UniRx. And I hope this will make you retain your sanity. Then I only have to thank you for your attention. You can contact me at joostvanschaik.outlook.com. My Twitter handle is localJoost. Of course, you can find me on LinkedIn. You can find me on GitHub. And the code you will have seen will be published on this link here. Now I only have to say two final thank yous. One to Mr. Andras Valvar, who actually will be talking about his MVP toolkit for Unity, which also uses UniRx. He actually set me on the track of using UniRx. I took a little bit different approach than he, but I'm pretty sure I wouldn't even have found UniRx without his project. And I also have to thank, of course, Alexander Myers for general inspiration and personal reasons for the time for the short but extremely memorable time we were once colleagues, and for organizing this, of course. Thank you all. I hope you enjoyed this talk and have a lot of fun in Up the Global XR Bootcamp. My colleague, Timmy Kokke, aka Source Code, will also be talking on this event. Maybe already has, but I don't know yet. Have a nice day. Have a nice week. And I hope we all see each other back in happier times.
All right.
Hello,
yes.
Rowan.
Hello, Joost.
Hi.
Thank you very much for this interesting talk.
I hope you liked it. I hear myself back.
Switch the.
I hear myself back.
Just a second. Sorry. So now the echo should be gone.
Let's try that.
Yeah. Um,
Great.
Very great. Yes. And yeah, it's a good overview of all the basic tools that each developer should know, right? All the programming tools. And let's see if we have questions. Not yet from the audience, but I also feel curious. What do you think about the developer tools that Microsoft has released with the MRTK? Like, what do you think is missing, maybe, or what is very great that you want to highlight?
Well, of course, a lot of things have been said already on this event. I mean, Renee yesterday talked about the awesome stuff around world anchors. Yeah, well, I'm very happy they created that, and there's more stuff coming. The MRTK itself, I think, is pretty indispensable if you want to make some progress to start to get things started and move around. Because well, if you have to write all that code yourself, it's very hard to do. Also, it makes for a more unified approach. That if I need to have another developer helping me out, I can say we use MRTK, and it's like the standard approach. It's Microsoft certified. This also makes it easier to talk with customers, like, this is Microsoft certified stuff. It's really good. It's approved. If you use enterprise stuff, it's sometimes a bit hard to use just stuff out of GitHub. Having said that, UniRX actually is that as well. So it's always a bit of a mixed bag, but the advantage of UniRX is it's a common and well-known approach. Also, it's very understandable, and it's open source. So if there should be a problem with the great man from Japan who created this, should he get under a bus, we can just pull it from. I hope not. He does, by the way. We can just pull it from GitHub and maintain it ourselves. It's no rocket science, but I'm glad it's there.
Yeah, very important to have these projects. And I have to say, I share the experience with Unity. It's always like things that work great in like C# native environment have a lot of problems when you try to build something in Unity.
Oh yeah.
And yeah, it's a really tough thing. I don't know what could be done, right, with Unity, because they have like their platform basically, and like to keep things compatible, everything. I don't know, what do you think could Unity do to help developers?
I have a pretty clear idea what they could do. They could get or improve their QA, because moving forward on a Unity version is like taking a blind step into a minefield. Something is going to break, but you don't know why. I always advise a cautious step. I do some tests, or let other people take the plunge, or look at Microsoft. Usually we take the version that's approved by the MRTK, because the people with Microsoft suffer the most pain. Unfortunately, they have taken that step in Microsoft, and no one is left behind. They're now sitting on a 2018 version, and we need ARM64, and it doesn't support that. So now this summer, I actually, for the first time in my life, I walked before Microsoft, but only after confirming, does this work? Yes, it works. Actually, the only thing that doesn't really work in the current MRTK is not caused by the MRTK, but by a Visual C++ compiler error. So it's always juggling, Oh, you don't know. If you use the menus, they have the menus, they can float very smoothly through the menu. If you click that checkbox that says move smoothly or move like this. Then all the menus will, after the first move, they will get a width of 0. So you will just see them. You will see them very short and then move very quickly, like they disappear in a black hole or something. And that has nothing to do with the MRTK. That has nothing to do with Unity. But then it goes wrong in C++. So it's always a bit like juggling. You have like the HoloLens. You have like C++, you have Visual Studio, and you have Unity. This was a very unusual thing, that things actually went wrong in C++. I'm used to the fact that things go horribly wrong in in Unity. So it's always dangerous to move forward. The best thing is stay on the LTS, the long-term service, because that's the least experimental branch, and usually the things don't break that hard. Knock on wood.
Right. Interesting. Yeah, I didn't know about that. The C++. I'm not sure, it's a bit off topic, but I remember that Unity dropped the .NET scripting backend in favor
Yes.
of C++ one. So
That's correct.
Was supposed to improve things, right? That they can focus on one thing only. Yeah.
Yeah, so the crazy thing now is you write your code in C#, and then it gets transpiled. That's the only word I can name to a C++ solution that I can't read. I think only a few people actually understand C++. That is, compared to the people who understand C#. C++ is more or less magic. And what the C++ it generates is about as readable as JavaScript generated by a generator. Fortunately, I've blogged about this some time ago. You can jump through some hoops that you can actually run with the right checkboxes in Unity. You can generate a special solution that actually still is C++, but you can attach the C# debugger to it. Only it is very slow. So if you try to debug it, you have to be patient. It crashes frequently, and if you try to debug timing issues, good luck to you. Because that won't work. So it's difficult, but yeah, developing for HoloLens is challenging. The rewards are also very big. It's like doing practical magic, and when you do magic, sometimes you get like the magic story with Mickey Mouse, that he magicked the brooms to do work for him, and then it became too much, and sometimes things go wrong, and then you have to just adjust to that. Take that in your stride. It's also challenging to find a solution around it. This is what we developers do: solve problems.
Right. Yeah. It's always like there's always a way with some hacks or workarounds.
Oh yeah.
But it's interesting, all these like grown problems with Unity, and I also see like Unity is really the most popular engine for XR development, but I also really try to look into Unreal Engine, just because I hope that they have a better setup there. But do you have experience with how things work in Unreal compared to Unity?
Really not at all. I mean, like you said, Unity is the most popular one. I jumped into that because it was the only thing that was available. And let's not forget, they have a lot of QA problems, but it allows you to do things that very easily that would take an enormous amount of work otherwise. I mean, I have in ye olde days, I've written my own game engine, physics engine that was only 2D. It was a lot of work, a lot of work. And now I can just spawn things, create a cube, and it creates a cube. Bounce this cube of another cube. Oh yeah, sure, no problem. It creates some other problems, but we can mitigate that. So I don't know anything about Unreal.
Well, at least I hope that having the competition will force Unity to like work harder on their problems.
That may help. Yet I think that most Microsoft developers will gravitate towards Unity because, well, C# is what they know.
Right,
Same
right.
reason why Blazor is so popular. We know C#.
Yeah. All right. Yeah, we still don't get questions from the audience, but
yeah, I think we're past the 50 minutes
we
remark. So
can basically wrap it
yeah,
up.
it's early in the morning here, so maybe people are still asleep. Anyway, it will be recorded, so people can have a look at it if they want.
Right. Anyways, I want to thank you again very much for this interesting talk, and
You're welcome.
For your contributions to like the open source and like helping developers. I think is very important.
I like that. Yeah.
Yeah. So, yeah, good work, and enjoy the rest of the conference. And
yeah, I'll be doing your work in next round. I'll be moderator. Oh, okay,
right.
so you can now sit back and relax, I think.
This is my last session. That's right.
Okay, prima. Bye bye.
Yes. Bye bye.